Well, hi once again, and today we're gonna keep on working on the angles and similarities exercises of the Regents Geometry August 2025 exam. For this exercise here, we are given a trapezoid. And something we know is that both bases of a trapezoid, so sides HS and JO, are parallel between each other. Therefore, well, that's on one side, no? First. And then we have a triangle here where the sum of the three angles has to be 180. So we can find this angle by doing 180 minus 80 minus 30. And that's going to be equal to 70 here already. And then we are asked to find angle HSA. That's going to be lying here. But what happens? As we have two parallel sides here, these two parallel lines, and then a transversal line, we can color in green here. These two are going to be alternate interior angles. So this one is going to be also 70 degrees. Therefore, we are going for the fourth option here. Let's now go with number 7 here. We have a triangle ABC and then another smaller triangle DBE, we could call it, no? And they tell us some of the side lengths, no? So AD is 8, which is here. DB is 4. Therefore, this total side length AB is 12, the sum of both, and DE is 6. And we are asked about AC, which is the one here. What happens? Both these triangles are similar. There is a similarity between them. Why do we know that? Because both share the angle at B, and at the same time, they have two parallel lines here, and they also share a second angle. So by the angle criteria, we could say triangles ABC is similar to a triangle. The other one, we can call it DBE by angle. And now that both are similar, we could say that as this here, the bigger side length is 12 and the smaller one is 4, the ratio is 3 to 1. And therefore, if this is 6 here, the other one has to be 3 times bigger. So it's going to be 3 times 6 equals 18. Therefore, we are going with option number 2 here. Let's now go with number 10. We have a circle here and seconds PCA and PDB are drawn. We are given some lengths here, no? So PD is 10, that's one is here. Then we have BD 12, the one here, and PA, which is the whole thing here, is 17. And we are asked about PC, which is the external part of this one. We can call it X. So what happens here? There is a formula which states whole. Yeah, we can move around. Or external times whole equals, I can move myself around, external times whole. And this means here that the external here on the top one is X. The whole is 17. The external in the lower one is 10. And the whole thing here is gonna be 27, no? Yeah, it's gonna be 22, the sum of both. And now we can solve this, and we are gonna get that X equals 220 divided by 17. And that, if we write it in the calculator, what are we getting there? The answer is gonna be 12.94. And if we want to round to the nearest tenth, it's gonna be rounding down to 12.9. Therefore, the answer is the third one here. Let's go now with number 14 here. They gave us, again, a big triangle that inside has a smaller triangle also similar to it because of the same reasoning, because of the angle-angle criteria, no? Therefore, as both are similar, and then they also tell us the mid-segment DE is drawn. This means that if this length is L, this also has to be L, no? And the whole thing here will be 2L. So now they also gave us D, which is x plus 3, and 3x minus 5. So we know that 3x minus 5 has to be double x plus 3 because it's in the mid segment, no? Because of the similarity. Therefore, we could write that 2 times x plus 3 equals 3x minus 5. 2x plus 6 would be equal to 3x minus 5. And now if we want to solve for x, we can move the x's to the right. And the numbers to the left, it will be 11 equals 3x minus 2x equals 1x. So x equals 11. Therefore, d is just x plus 3. Therefore, it will be 11 plus 3, which is equal to 14, which is the second option. Let's continue with the next exercise here, number 27. They tell us we have endpoints of CAS and they gave us C and S, and we are looking for the coordinates of A, no? Where they gave us this ratio, 3 to 2. Okay, so the first thing we could do is draw in C, that is minus 3, 1, so it's gonna be here, and 7, 6 is gonna be here exactly, no? So that's S. Good. So now that we have that, we could check, we could do the line in between them, no? Because somewhere there is gonna be A. And now we can see that from C to S, we went 10 to the right, no? This is 10, and this is gonna be 5. We are going 5 up. And they also gave us the ratio of CA to AS is 3 to 2. That means that CA is, 2/3. No, sorry, 2. CA is the longer one. So it's 3 over 2 plus 3, which is equal to 3/5 of the segment, of the whole segment of CS. And what happens? CS, for getting into CS, we did 10 to the right and 5 up. So out of the 10 to the right, we are going to be taking 3/5. So it's going to be 3/5 times 10, which is equal to 6. So we are going to go 6 to the right from C, and that's getting us here exactly. Well, it's getting us first there, no? And then how many up? It's going to be 3 divided by 5 times 5, no? Out of the total number of units we go up, we take 3/5. And that's going to be equal to 3. So then you go also 3 up. And that's getting us to this point. That is where A will be located. So out of the 5/5, out of the total, 3/5 came from CA, and from A to S is 2/3. And the coordinates of A, now we could give them directly. Well, we can look them in the diagram already, no? It's gonna be 3, 4. 3 to the right and 4 up from the origin. So that's why. So that's the answer here. Let's check this next exercise. It's a very easy one. What do they tell us? They tell us that we have an isosceles triangle KLM. That means that two of the angles are the same and two of the sides are also the same size, no? So we could see already that the equal angles are these two. And they also gave us angle at K is 15. Therefore, this other angle is also 15 here. Now we are asked the angle at KMN. So that's going to be the one here, the one we are looking for. But what happens? The sum of the three angles at any triangle has to be 180. Therefore, we are going to have 180 minus 15 times 2, because 2 are the same size. That's going to be 180 minus 30, which is 150. So we could draw this one is 150. And then, as this is half a circle here, no, it's a horizontal line, has to be 180. Therefore, 180 minus 150 gets us 30. Therefore, the angle we were looking for at the beginning is just 30 here. That's the one. And now, lastly, let's go for this exercise, number 31, and we are asked to do it with the compass and straight edge. So we are going to jump into another window to do it over there. So here we are on this tool to be able to use the compass, and they gave us something like this, no? Point A and line BC, no? Between points B and C. And they are asking us to reflect it over point A over the line BC, no? And we are only able to use, yeah, the compass and the straight edge, no? So first of all, we need to find a perpendicular line to BC that goes through the point A. To do that, we are going to use the compass. So we are going to locate this edge over there and the pencil or the pen on B. And now we are going to do, with that length, we are going to do something like this. We are going to draw this line, and what can we see? Now we got the point we had already at B, but a new point here. And now we can take this distance without changing the distance at all. You can draw one line like that, then place this again at B, and we want to draw a bit down again here. And where both intersect, as we can see here, where both intersect is gonna be perpendicular and should be going through point A. So let's check that here. If we draw it correctly, yeah, should be something like this. So now we can draw with the pen, and this is 90 degrees, as we can see here, and the reflection would be here, A prime. So that has been all for this set of exercises, and we will see us in the last.